Welcome to Let's Talk Micro.
Hello, dear listeners. Welcome to another episode of Let's Talk Micro. As always, I hope you had a great week. And you can always find Let's Talk Micro on Apple Podcasts, Spotify, Google Podcasts, Goodpods. Wherever you listen to podcasts, you can find Let's Talk Micro. As far as social media, I am on Instagram, TikTok, and YouTube as Let's Talk Micro, on LinkedIn as Luis Plaza, on X as Let's Talk Micro 1, and I have an email address which is letstalkmicro@outlook.com. So either via social media or via email, you can reach out with any suggestions, any feedback. They are always welcome and appreciated. So please go ahead and subscribe to the podcast, download episodes, and if the app allows you to do so, please go ahead and leave a review. Thank you so much for the support. And as you know, the Let's Talk Micro podcast does not have any sponsors. So if you want to support the podcast in any way, there is a Venmo link and there's also a Buy Me a Coffee, KO-FI, both links available on the show notes. And if you are looking to learn more about antibiotics, please check out www.learnantibiotics.com and the Learn Antibiotics book available on Amazon. These resources include cheat sheets, practice tests, games, and more, and they are being used by thousands of people worldwide and may be helpful for you or your colleagues. Great resources from Dr. Timothy Gauthier, a very passionate pharmacist, and he has been a guest of the podcast. So I definitely recommend these resources. And speaking of antibiotics, stay tuned. The next episode of the AMR series with Andrea Princey, it's coming your way. Well, if you haven't checked out the previous episode, please go ahead and do so. It was a re-release. It was an older episode that was originally published as episode 75, and it was about Bacillus. And like I said, since the podcast, now has more followers and has more reception, sometimes, some of those older episodes that didn't get like a fair chance as the podcast grew, and sometimes, new listeners, they maybe listen to the new stuff. So I thought it was a good time to re-release it, especially since I had just done a series about Corynebacterium. So now you kind of have all the episodes next to each other on the list of the podcast episodes. You have the series about Corynebacterium, and then you have the series about Bacillus. All in all, it was a great episode, with a lot of information, and in it I went over the genus Bacillus and also over related genera. I talked about groups, and this is something that I have talked about before in the podcast, and organisms sometimes, based on that they're very close to each other, they're very related, very similar, they are grouped in something called a complex or a group. And I have mentioned groups like Enterobacter cloacae group. There's other groups like Burkholderia cepacia and things like that. So I talked about that. I went over Bacillus cereus group, Bacillus subtilis group, and Bacillus circulans group. I went over some diseases. I talked about the gram stain, how Bacillus can stain variable. And I also talked about, and this is something that I always like to emphasize to students, that when you're going over gram stain, definitely when it comes to gram-positive rods, associate those terms. You have terms like boxy for Bacillus, long and thin for Lactobacillus, palisades, V-shape, carineiform for Corynebacterium. So this is something very useful. And when it comes to microbiology, you're always associating those terms, those key words that it might help you when you're taking a test, doing like a multiple choice, and you see something on the question that points towards the organism, so it helps you out. So definitely keep that in mind. And I also went over spores and their purpose. So that's something very important to know. And Bacillus, it has spores, and you can see those on the gram stain, like a clearing, like they don't take the stain. And I also talk about some methods where you can see the spores. So definitely check out that episode if you haven't already. Well, today's episode it was the original episode of that sequence. So it was episode 76. And with the same reason, since the previous episode was about Bacillus, and I started giving an overview, talking about things like gram stain, spores, different species. Then this episode is about media, and I thought it would be good also to re-release it. That way they will both be together, and for the benefit of new listeners, for the benefit of students, and even if you want to listen to it for a refresher, I definitely recommend it. So this episode is about media used for Bacillus, and I talk about media like MYP, which is mannitol, egg yolk, polymyxin agar. I also talk about PEMBA agar, which is polymyxin egg yolk mannitol bromothymol blue agar. And I also talk about some methods that are used to identify bacillus, and I talk about biochemicals like catalase. So all in all, a great episode. And as I said, if you haven't listened to it, I invite you to go ahead and do so. If you checked it out, this episode was originally published last year. So it will be a good refresher, especially since you just listened to Corynebacterium and now you refresh your knowledge on bacillus. So let's go ahead and listen to it.
So now we are going to talk about media, morphology, and biochemicals. So in the lab, how do we identify bacillus? What kind of media does it grow on? I mentioned in the previous episode that they are aerobic or facultative anaerobes, and they actually grow well in your standard media that is used in the lab. Of course, media that is selected for gram-negative rods is not going to grow there, of course. But the other media, like your blood, your chocolate, your PEA,
your CNA agar,
bacillus will definitely grow on. So as far as being team players and not being fastidious, they are definitely great team players, and they will grow on your standard media. Then as far as morphology, it is varied. So Bacillus cereus, it has large, spready colonies that are beta hemolytic. And when I say large, I do mean large. And they have like a waxy appearance, and they almost swarm. So if there's a large number of organisms, and those of you that when you subculture it, you definitely know that even you grab a tiny bit and then you just subculture that, and then you get a lot of growth. And then those colonies, they will definitely grow over others on the agar. So if you have a bacillus and there's something that you're trying to get out, go ahead and get it out as soon as possible, because that bacillus, more than likely, it will grow over it. So another member of the Bacillus cereus group is Bacillus thuringiensis, that I mentioned before, and the morphology is about the same. Then as far as Bacillus subtilis, it has large, dull, waxy colonies that may or may not be hemolytic. So definitely as we go along, remember hemolysis and how does that relate to Bacillus anthracis. Then we have Bacillus licheniformis that has large colonies that are beta hemolytic. There is also a member of the Bacillus cereus group that I didn't mention, but I am going to because of the morphology. And this is Bacillus mycoides. And I want to mention it, like I said, because of the morphology, because the colonies, they're rhizoid, and they almost resemble a mold. So I know definitely that some of you that work in the lab, you might have seen it and perhaps thought that it was a mold, right? You typically, when you have a mold, you see it, it looks like a little fluffy, a little hairy. And this species is actually, it's like that. It has like that hairy looking morphology. So you might definitely think it's a mold. So definitely remember it in case you ever see it in the lab. That doesn't mean that you have a mold. You might have a bacillus. Of course, with time, repetition, and looking at things over and over again, you definitely get familiar enough where you can tell them apart. But especially if you're coming in new, maybe a little bit inexperienced, just starting your work, you see one of these, you might definitely mistake it as a mold. Of course, you cannot just call something, we have to do testing such as gram stains and other things. But at least visually, that can happen. So as far as motility, most species of Bacillus, they are motile. And this is also important when it comes to Bacillus anthracis. And I will talk about motility when I do the episode about Bacillus anthracis. But basically, motility is movement by means of flagella. As far as biochemicals, they are catalase positive. Other tests, they include fermentation of sugars and indole production. But as far as testing that you do in the lab on the bench and stuff like that, even though you do see the fermentation of sugars and the indole production, it's mentioned in the textbooks. So we mostly do the catalase and we do the motility. The motility being very important when you have a non-hemolytic bacillus. But let's go ahead and talk about media. So I mentioned how significant Bacillus cereus is and that it can be found in food. So you definitely have agar that is used to detect it in food. One of them is mannitol, egg yolk, and polymyxin B agar. And this is abbreviated MEYP or MYP. So I am going to talk about MYP agar from Hardy Diagnostics, which has no affiliation with the podcast. So as the name says, it has polymyxin B, mannitol, and egg yolk lecithin. Additionally, it has nitrogen, vitamins, minerals, and beef extract. Mannitol is the carbon source for this agar. So if the organism ferments mannitol, the colonies will turn yellow. If it's not a fermenter, if it doesn't ferment mannitol, the colonies will be red. And by now, with the episodes that I have done, you're definitely familiar with how the process, right? How the process of fermentation works. So, when fermentation, so if the organism ferments that sugar, acid is produced. So you do have an indicator in the media that measures the changes in pH. So in this case, it's phenol red, which is also used in a triple sugar iron agar, which definitely go ahead and check out that episode if you haven't already. So you have phenol red as the pH indicator. And I mentioned mannitol. I know those of you in the lab, definitely you're familiar with mannitol. There's a popular agar that's mannitol salt, which is the same, it's the same principle. If the mannitol is fermented, it turns, the colonies are yellow. So this is what we're seeing here with the fermentation. We see a color change. So the medium has polymyxin B, which inhibits the growth of normal flora. And then organisms that produce an enzyme called lecithinase, that enzyme that hydrolyzes the lecithin that's in the egg yolk agar. This results in white precipitates around the colonies. Bacillus cereus does not ferment mannitol, but produces lecithinase. So the end product of this agar should be pink to red colonies with white precipitates around the colonies. And this is a very simple procedure. You inoculate your sample on the agar and then incubate it for 18 to 48 hours at 30 to 35 degrees Celsius in a non-CO2 incubator. So you need to incubate the plates aerobically. So then you examine for Bacillus cereus colonies, and they are pink to purple with a zone of white precipitate. It is recommended that the colonies are identified by procedures such as molecular procedures, or as mass spec, such as the Molotov. There's another medium that is polymyxin B, egg yolk, mannitol, and bromothiamyl blue agar. And this is abbreviated as PEMBA. Fisher Scientific sells some, and also Lyophil, which is an Italian company. I don't know if you out there, maybe you're familiar with Lyophil, but they do make some e-tests, and they're coming along with making some broth microdilution tests. And then the e-test strips that looks like they're like kind of like cardboard. They have like that cardboard look. So I don't know if you use them or not. I think all of them are for research use only. But definitely you might be familiar with them. So it's Lyophil, and once again, no affiliation to the podcast. So with this medium, with PEMBA, so the principle is the same, right? So once again, you have mannitol, which is for the fermentation, and then you have lecithin from the egg yolk. So as I mentioned, with the MYP agar, Bacillus cereus does not ferment mannitol but hydrolyzes lecithin. So with the PEMBA agar, you will expect to see the white precipitation because it will hydrolyze it. However, the pH indicator for this agar is bromothiamyl blue instead of phenol red. So instead of having pink to red colonies, if the organism is not a fermenter, you will have blue colonies. But if it ferments mannitol, then you will have yellow colonies. And once again, keep in mind with this media, that this is used to detect Bacillus cereus in food. So it's, you have your samples are from food, which, definitely makes sense because it's an organism that's seen, it causes food poisoning. There is also chromogenic media, which is also used to detect Bacillus cereus in food. And there is one by Fisher Scientific that is called Brilliance Bacillus cereus agar. And this one actually has a chromogenic substrate, which is, and bear with me as I go through it, 5-bromo-4-chloro-3-indole beta glucopyranoside, which is cleaved by the enzyme beta-glucosidase that is present in Bacillus cereus. And this results in blue-green colonies. It also comes with a supplement that has polymyxin B and trimethoprim. And trimethoprim, it has activity against Staph aureus, Enterococcus, and other Bacillus species. So the plate, is inoculated at 37 degrees aerobically for 24 hours. Once it's ready, then you examine for those blue-green colonies. You also have, other chromogenic agar, and this is which uses the phospholipase C activity. So as far as instruments that identify Bacillus, so you do have, like the Vitek and the Molotov. They do identify them, and actually Vitek has a Vitek 2 systems. They have a card that is called the Vitek BCL card that identifies Bacillus. But to be honest, I have never seen it in any other places that I have worked on. There are also API tests that identify Bacillus. I haven't worked with them. As far as API, and I think maybe some of you in the audience, I don't know how much they are used outside of the United States. In the US, we use them, but as we start moving towards Molotov and other things, we might just not be using them anymore. But I did work with the API test, like the API E, 20E, and 20NE, the 20E that you use it for Enterobacterales. I was never a fan of that test because, it's definitely, it's involving, you have to go ahead and make your suspension, make sure that you fill the little wells, then you incubate it, add your reagents the next day, and they work well for your classic organisms. But when you have something that's a little unusual or abnormal, they might not work well. And I'm not a fan of tests that you see some reactions, you get a number, and then that combination of numbers gives you a result. Like this 4-hour kits that you use for anaerobes, because they can be very subjective, and then you can start, maybe have a positive, maybe have a negative reaction. So you can play around with the numbers so you can get the result in a way. So it's just not, I don't know, I don't really like it. I prefer things like the Vitek or the Molotov, which in my opinion, they give you a more accurate result. So I mentioned the Molotov can identify it, but the identification can be affected by the spores. And while we're talking about systems, this is something that you have to make sure that as, as a microbiologist, especially as a upcoming microbiologist, that you just graduated, you're starting your job. When you are setting, using these instruments for ID, you have to make sure that the organism, it's in the database. And this is something that I've seen with moldy users. That, right, you put your organism in, you get an identified, it fails on the moldy, and you're like, okay, well, let me go ahead and put it on the Vitek. Or the same thing, that you get an ID that's questionable on the Molotov, and then you said, okay, let me put it on the Vitek. So basically, you're trying to confirm something or identify something, but you have to make sure that if you're using that particular instrument or that particular card, you have to make sure that the organism is included in it. And this is very simple, especially, Vitek users. You can go online and you click, for example, gram-negative ID card package insert, gram-positive ID card package insert, and then check if the organism that you are trying to confirm that name is actually in there. If not, then don't use it, because you might get a different result. You might get some sort of misleading result. So this is something to keep in mind when you are trying to identify anything. Make sure that that particular test or instrument actually has that name included in the database.
So in the lab, beta hemolytic species of Bacillus, and just going back to the Vitek real quick,
your GP card doesn't identify Bacillus. So if you're trying to go that way, don't use it for that. So in the lab, we can presumptively identify beta hemolytic species based on the gram stain, morphology, and catalase. And I'm definitely going to talk about, like I keep mentioning, I'm going to talk about Bacillus anthracis in a separate episode. But if you see a beta hemolytic Bacillus, catalase positive, gram positive rod, you can go ahead and call it Bacillus. So, and I talk about presumptive IDs, which typically, you can call the organism, you can, identify it based on certain criteria, right? A very common one is E. coli, where you have a lactose fermenter, flat and dry, indole positive. You can call it E. coli. But with Bacillus, you can apply this criteria. If your Bacillus, if your suspect colony, it's not hemolytic, then you need to do a motility test to rule out Bacillus anthracis. Bacillus anthracis is non-hemolytic and non-motile. And like I keep mentioning, I will talk about motility on the episode about Bacillus anthracis. So let's go ahead and bring it all together so we can have it all nice and summarized. So definitely, with Bacillus, we have talked about the gram stain, we have talked about spores. As far as the colony media, it grows on your regular media that gram positive grow on, your blood, your chocolate, your PEA, your CNA. So it grows there. Colonies, you can have different morphologies, but typically they are large, they are spready, and then you have hemolysis, and some may not. So definitely, I talked about Bacillus mycoides, which has the rhizoid colonies, so it looks like a little hairy. So definitely, if you're listening to this episode, go ahead and Google it and commit that morphology to your memory, sorry. So definitely keep that in mind. And then, we talked about media. So typically, the medium that you use for Bacillus cereus in food. So it has mannitol, which, if it's fermented, you have a pH indicator. And then fermentation is yellow. And depending on the indicator, if you use phenol red, you have red colonies. If you use bromothymol blue, you have blue colonies. And then if the organism hydrolyzes lecithin, you get those white precipitates around the colonies. So if you're a microbiologist out there that works in the food industry and you work with this agar, go ahead and send me an email and we can discuss the possibility of doing an episode where we can talk about that. It's very interesting seeing this agar, and how it works. But like I said, that medium is used for Bacillus cereus in food. So keep that in mind. And definitely, we talked about how to presumptively identify Bacillus, colonies beta hemolytic, catalase positive, you can call them Bacillus. And some of the instruments that you work with in the lab, such as your Vitek and your Molotov, they can identify Bacillus.
And that, my dear audience, it's the end of this episode. I hope you enjoy learning about Bacillus, media, morphology, biochemicals. As always, I enjoy sharing this information with you. Thank you so much for the support. These past 2 episodes were a great refresher. If maybe you're a student listening to the first time, if you're a new follower, or if you listened to them before, now it's time for a great refresher. They go hand in hand with the Corynebacterium episodes. So thank you so much. And as I said, stay tuned. The next episode of the AMR series with Dr. Andrew Aprinzi, it's coming your way. You don't want to miss that. So please continue bringing that passion to what you do. It's so important. You do such great work. So, as always, stay motivated, stay safe, and of course, continue talking micro. Until the next time. Bye.